So this is going to be a quick single example video on how to write the equation of a line through 2 points. I'm going to show you both how to write it in slope-intercept form directly and how to use point-slope form to get into slope-intercept form. And we're going to start out with slope-intercept form, which is the one that most students are most familiar with. So y equals your slope times x plus the y-coordinate of your y-intercept. All right, so y equals mx plus b, m being the slope, b being the y-coordinate of the y-intercept. The first thing you need to do is find slope. Now, a lot of people focus really hard on the slope formula. I prefer not to memorize formulas. I prefer instead to understand why they are the way that they are. In order for a horizontal line to have a slope of 0, you have to have the difference in your y values in the numerator of the fraction rather than your x's in order for the division to actually turn out to equal a slope of 0. 0 is the number that separates positive numbers from negative, and as you transition between a positive slope and a negative slope, you have to go through a horizontal line, just like you have to go through 0 to go from negative to positive. All right, so if I need the change in my y values in the numerator, I'm just going to start with, I'm going to choose a second point to start with. All right, now all I need to figure out, once I understand how slope is kind of set up, I need to know which of these is my y-coordinate, right? It's always the second number in your ordered pair. All right, so 42 is the y-coordinate of that point. That makes 21 the x-coordinate. Coordinates from the same point have to be above and below each other in the slope formula. And because we're looking at how the y is changing as x is changing along a line, that's why we're using subtraction. Because change looks at the difference between values, and difference in math is subtraction. Right? Our other point, the y-coordinate is going to go on top, the x-coordinate on the bottom, and then we complete our subtraction. 42 minus 16 gives us 26. 21 minus 5 is equal to 16. And I'm going to go ahead and just divide those to get a decimal answer. All right, if I divide that, I'm going to get 1.625. Ordinarily, we would leave this as a fraction. We would just simplify it. But I'm completing this problem for a data analysis problem. And in statistics, we often go ahead and work our slopes out to decimal values. All right, from here, so this was kind of like step 1. From here, we need to go ahead and substitute our slope into the formula. So we have y equals the slope of 1.625 times x plus our y-intercept. Now keep in mind, this is a lowercase letter b. I have 3 different variables here. If I want to try to figure out what b equals so that I can complete this equation, I need to be able to substitute values into the other 2 variables. That's where these points are going to come back in. Now, it doesn't matter which point you use, you should be able to get the same exact value for your y-intercept. All right, I'm going to use this first one because it has smaller numbers. My y-coordinate is going to go in place of my y variable, so 16 equals 1.625 times my x value, which is 5 from that point, plus b. Now I have a single variable equation that I can actually solve. All right, first thing I need to do is simplify the 1.625 times 5. That equals 8.125. And the rest of the equation kind of fills out around it. And in order to isolate b, I need to remove the 8.125. Now this is a positive value. These 2 are being added, so I need to subtract the 8.125 from both sides. So 16 minus 8.125 equals 7.875. That's the y-coordinate of my y-intercept. Now you're not done yet. There's still one more step. Step 3, take this value, substitute in place of b in the slope-intercept equation. Y equals 1.625 times x plus my y-coordinate of my y-intercept, 7.875, And now you're finished. You have your equation in slope-intercept form. Now this has several moving parts as you're going through, which can get confusing to some students. That's one of the reasons that I like point-slope form. All right, this form takes the y variable minus the y coordinate from a point that's on the line. And that's set equal to the slope times the quantity, x minus the x coordinate from the same point. All right, so you need a point that's on the line and your slope, and you can write your equation in point-slope form. Now we already have our slope from here, so step one, basically doing the same thing, our slope is equal to 1.625. I'm not going to repeat the work because we already have it written over here. Step two is to use one of the points that we know is on our line and the slope to fill in this equation. I'm going to use this first point again, just like I did previously. So I have y minus the y coordinate from this point, which is 16, equals my slope, 1.625, times x minus the x coordinate from the same point. And now I just need to do a couple of algebraic steps to isolate y to get my equation into slope-intercept form as well. Now, if you want to leave it in point-slope form, at this stage you would be done. This is an equation of a line. But if your directions say to write your equation in slope-intercept form, then you would want to go through and use distributive property. And then isolate y by undoing the subtraction by 16. To do that, you have to add 16. Now notice that over here we had 16 minus 8.125. Here we have negative 8.125 plus 16. We're basically ending up doing the same steps. They're just organized a little differently. And that's why we get the same answer, no matter which form you use. Okay. And that is how you write the equation of a line through 2 points using 2 different forms. All right. I hope this helps. Let me know in the comments if you have any questions.